Thanks for all of you for coming, especially students. It's nice to have friendly faces in the back and the front. I'm going to be talking a little bit about prairie dogs today. And I never set out to be the prairie dog guy. I'm not sure anybody does that. I kind of stumbled into these critters, and what I stumbled into was one of the more polarizing creatures of the West. You can see how different people view these things with a quick YouTube search. You'll find two different types of videos. One type of video will be pleasant music playing and baby prairie dogs kissing each other. And the other type of video will be prairie dogs exploding, which I think illustrates fairly well how they're viewed in a lot of places. Just a brief outline. We're going to go through some natural history, historical numbers and range. Prairie dogs is a keystone species. Relationship with livestock is where it gets really interesting. Real briefly on policies. When talking about polarizing creatures like prairie dogs, I tend to stick to the science as much as possible, and that keeps me off of a limb. Future directions and a little bit of take home. We have several species in North America, several species of prairie dogs, including the Utah prairie dog on the left, top left, white-tailed prairie dog on the top right, Gunnison's prairie dog in the bottom, and then the Mexican prairie dog on the right. Most common and widespread species in the Great Plains is the black-tailed prairie dog, and these are the little guys you'd be seeing along roadsides in this region. These only weigh about 1.5 to 3 pounds, live in family groups called coteries, and those are grouped together into larger colonies. Really, really complex social interactions. Some would call almost a language. They have different calls for different types of invaders or predators. So a person versus a coyote versus a golden eagle will all get a different alarm call. They eat primarily grasses. Roughly 80% of what they eat is grasses, but also some little forbs and wildflowers. Females typically produce about 3 to 5 offspring per year. And again, I mentioned very advanced alarm calls, very advanced social interactions, which range from very, very friendly to very, very fierce. This is the stylized version of what a prairie dog town might have looked like. Typically, they have about 20 to 50 entrances per acre. And what that breaks down to is if there's a lot of forage in an area, they'll be more densely packed. If there's not a lot of forage in an area, they'll be further spread out. They use these burrows for thermal relief. It's much cooler underground, just like in your basement, and also protection from predators. The mounds themselves are fairly interesting. They serve a lot of purposes. One purpose is simply getting rid of the excavated material. It needs to be put somewhere. But they also provide a lookout tower for predators. And I had to look this up. If you've ever worked on carburetors, you should be familiar with Bernoulli's principle. Basically, by being elevated, the air moves faster across them, which draws air through the burrows. So they actually are self-ventilating, which is helpful. So taken together, all those species that we talked about, excluding the Mexican prairie dog, occurred across most of the Great Plains and much of the Southwest. Estimates range from 40 million hectares, which is about 100 million acres, to over 100 million hectares, which would be about 250 million acres, would have been within the colonies of these animals. To put that in perspective, I said up to 250 million acres. Nebraska is about 49.5 million acres. So up to 5 Nebraskas of prairie dog towns across North America. Some of these were likely huge. Early reports from European settlers moving across Texas, many square miles, up to 40 miles across was one of the reports, a single prairie dog town. Others of these would have been smaller and more scattered. The black-tailed prairie dog that we have in this area is the one that forms the largest colonies. Many of these other species form smaller colonies that are less densely populated. Soil type, slope, grazing patterns of large herbivores, and fire all would have interacted to determine how big these colonies were and how spread out they were. A lot of the debate that goes on about prairie dogs' historic distribution centers on how much acreage they actually covered, but it also talks about how far east they would go. I would say the best information we have puts that eastern boundary at about the 98th meridian, right about the western edge of the tallgrass prairie. Once you get into the tallgrass prairie of eastern Nebraska, basically these animals need to be able to see to avoid predation. Once you get into the tallgrass prairie, there's simply too much vegetation for them to keep up with it, and they're susceptible to predation. So as I talk today, try to keep this scale in mind. We're looking at something like 100 to 250 million acres historically, ranging from Canada to Mexico. All right. There's been a lot of discussion over the years of prairie dogs as a keystone species. Some other keystone species that might come up would be, people describe the wolves of Yellowstone as a keystone species. But actually the original keystone species was a starfish. The keystone species designation first was only applied to predators. This starfish, when they were removed from their ecosystem, the biodiversity was cut in half. Okay, it was the starfish had an inordinate amount of effect on the ecosystem that it was a part of. We've had several different definitions of keystone species over the years. Generally, it's a species that defines its ecosystem and promotes biodiversity. So more recent designations we've had, I mentioned the wolves, but also beaver could be considered a keystone species. The bison has been considered a keystone species of the North American prairie. There has been a little bit of resistance to using that term at all because it implies somewhat that one species is more important than another. And if you've read any of Aldo Leopold's work, you would see there'd be some pushback against that. But the term has been thrown around quite a bit, and it's been a little bit poorly defined. So some researchers in the late 90s went about critically evaluating the idea of the prairie dog as a keystone species. So the requirements that they settled on for a species to be a keystone species: large effects on community structure in relation to biomass and abundance. So a few of this animal have a huge impact on the rest of the environment around it. And the second criteria would be low ecological redundancy, which means there's not a lot of other things out there that can fill the same niche. So to test this, this is Kotliar, 1999. They went to see if prairie dogs do in fact have large effects on community structure. And what they identified were approximately 200 vertebrate species that use prairie dog towns. Whether that's intentionally or incidentally is a different question. Roughly 117 have some relationship with prairie dogs, whether it be predator-prey, or they use that low structure vegetation, or actually use the burrow habitat. And approximately 8 depend on prairie dogs for their survival or for maintaining historical populations. Now, this was a very strict set of criteria. These 8 species absolutely depend on prairie dogs. Many of those 117 likely do, but just simply did not meet the very strict criteria that these researchers used. So just as a few examples, prairie dogs are used heavily as prey animals by species like the ferruginous hawk, the swift fox, the golden eagle, and especially the black-footed ferret. And the black-footed ferret gets a little bit of extra consideration because it's listed as an endangered species in the Endangered Species Act. In the United States, that means fairly strict legal protections for that animal and also animals that it depends on. Where prairie dogs are not available, we do not find black-tailed prairie dogs. Low structure vegetation, very important to, I have to check my notes on these. The deer mouse, horned lark, mountain plover, and the northern grasshopper mouse are all obligate species of prairie dog towns. And then there's these little guys. Prairie dogs create burrows used by burrowing owls. Burrowing owls is actually one of the ways I got interested in prairie dogs. These are a diurnal owl, which means they're active during the day. They eat primarily insects and rodents, and they live in burrows, hence the name. They don't actually dig their own burrows, though, so the burrowing owl idea is a bit of a misnomer. They might slightly modify them in some situations, but they don't dig their own. So without prairie dogs to produce burrows, we really don't have burrowing owls. Again, from a legislative perspective, burrowing owls in the United States are considered a species of conservation concern, which doesn't afford them any real particular rights. In Canada, however, they are endangered. These burrows for the owls provide a lot of the same things they do for prairie dogs, someplace to have a nest, relief from temperature, and also some protection from predators. So, as far as the large effects on community structure goes, the conclusion of these researchers is absolutely. There are a lot of species that require habitats produced by prairie dogs. So the next question then is, do other species or natural phenomena create these things? Or can humans adequately replicate this function? So if we don't have this low ecological redundancy, well, maybe we don't have a keystone species. This is one of my favorite scientific debates. I think it illustrates really well how scientists argue. Miller, Vermeer, and another researcher went on about a 12-year, 6-publication debate trying to answer this question. So I think it illustrates scientists argue on large timescales and in dense publications. But the general conclusion was, in some ways, maybe, in some ways, we might be able to do this. Bison, grasshoppers, and fire all produced large areas of short stature vegetation and bare ground. We can do that with cows, too, to a degree. The problem with that, well, because of that, folks have argued that this ecological role may be a little bit overstated. There's a couple counters to that. First, modern grazing management is not designed to create areas that look like prairie dog towns. We can do it. It's been highly discouraged for many, many years. Modern grazing managers are very good at using, I just thought of this today, I was proud of it, the Price is Right principle of grazing management. As close as you can get without going over, right? Use as much of the vegetation as possible without causing degradation. We're very good at that. We've gotten very good at that. We are not set up currently to reproduce conditions found on prairie dog towns. Not to say it couldn't be done. Second, though, the main counter to this is those burrows. The burrows themselves are not something we can replicate. And we've done this artificial burrows for burrowing owl nests. And sure, we can do it on small scales, but on the North American scale, we simply can't replicate it. And also acting as a prey animal. I haven't seen any volunteers to act as a prey animal on 100 million to 250 million acres. So, conclusions of these researchers were, yes, low ecological redundancy. This is a species that serves in a role that we cannot adequately replace. So, by those two criteria, and because of all of these, I apologize, that's a little smaller than I expected, all of these different relationships, we have a keystone species, which is incredibly important for other grassland species. Once occupied 100 to 250 million acres in North America, what happened? We still have prairie dogs in all of these states. We still have all of these species. But like other grassland species, conversion to row crop agriculture has made a big dent in populations, particularly in the eastern parts of the range. Unlike other species, widespread poisoning has also played a role. Populations reached an all-time low in about 1960 at approximately 1.5 million acres, which, if you're doing the math, reduction of 90 to 99% in terms of area covered. And we've also introduced sylvatic and bubonic plague to these populations, which is not a North American disease. It's not something the species had to deal with before, which has been very problematic. Something to point out on that 1960 number. So 1960 was approximately our lowest populations. What that means is, for as long as most of us have been alive and paying attention, prairie dog numbers have been going up. Okay? So in our perception, you know, you might look out and say, when I was a kid, there was no prairie dog town in this pasture. These things are blowing up, right? But in reality, we might have gone from 1% of historical populations to 2%. So even though we've seen an increase, it has not been any increase at any large time scale. So the reasoning behind this widespread poisoning has been competition with livestock. And if anybody's been on a prairie dog town, you fully understand where that idea comes from, right? We're talking very low stature vegetation. We're talking lots of bare ground. From a traditional range management perspective, very poor rangeland health. The trouble with that is this is actually really poorly studied, poorly understood overall. It seems obvious, but it was described by a couple of authors, Augustine and Springer, in 2013 as surprisingly sparse, the literature on competition with livestock. Several proposed mechanisms, they seem fairly obvious. Actually consuming forage is one. The prairie dogs I mentioned earlier eat primarily grasses. We mostly want to feed grasses to cows. They also clip vegetation that they don't eat in order to improve visibility. They build mounds, which creates bare ground. And then they can also change plant composition, species composition, in ways that don't necessarily favor livestock production. But from an ecological perspective, in order to actually demonstrate competition, we need two species that use the same resource, and we need one species to be adversely affected by that use. Okay? Using the same resource we call dietary overlap. Dietary overlap between humans and range cattle would probably be a couple percent. There might be a berry out there that I wanted to eat and the cow ate it instead. Contrast between me and another human out here might be about 99%. There's probably one thing we don't like, that you like, that I don't. Dietary overlap between cattle and black-tailed prairie dogs is fairly high, on the order of, similar to sheep actually, sheep and cattle, 60% in mixed grass prairie and up to 64% in short grass prairie. Those numbers depend a lot on how much forage is available, what types are available, so they depend on things like drought and stocking rate, but these are the best numbers we have. The other thing we need is, they also have the ability to reduce forage availability on town by 10% to 100%. So a prairie dog can bite closer to the ground than a cow can. So in drought conditions or high concentrations, they're able to reduce that forage to a level that cattle cannot actually feed. But the second part of that definition, we need one species adversely affected by that shared use. Strict ecologists would probably require a decrease in reproductive fitness, which would mean that cattle feeding on prairie dog towns would have to wean fewer calves than cattle feeding someplace else. That's a little bit tougher to measure, and we usually, in the applied sciences, I guess, don't hold ourselves to quite that high of a standard of proof. So the proxy that's typically used for this is weight gain. So if livestock that are grazed on prairie dogs towns or in the presence of prairie dogs gain less weight than those who are elsewhere, we would consider that competition. So how do they translate? What actually does happen here? We've fairly clearly demonstrated we have two species that are using the same resource. Does it reduce weight gains? Story of my life dealing with prairie dogs. Fewer studies than I'd prefer. The citation you'll see most often, Merriam, 1902. Merriam, 1902, estimated that 256 prairie dogs eat the same as one cow, and that annual loss was 50 to 75% of the producing capacity of the land. All right, great. Except we never got a formula for how those numbers were derived. There was no evidence given for the 50 to 75% number. It is possible that this was a good number and we just didn't get any documentation behind it. I'd like a little higher standard of evidence. So we move a little further. O'Melia et al., 1982, found no statistical difference in steer gains in Oklahoma shortgrass prairie between pastures with or without prairie dogs. However, they did extrapolate that out a bit and found estimated market values lowered were about $14 to $24 per steer for steers that were raised in the presence of prairie dogs. Now again, that's not a statistically significant value, meaning they didn't have enough power in their statistical analysis to claim that this is a real difference, but if you're a cattle producer, $14 to $24 per steer might wake you up a little bit. But another problem here, Vermeer et al. In 2004 reanalyzed these data, found reduced winter gains but no statistical difference in the summer. And as is often a problem in range research, we had a really small sample size. We only had 6 steers per treatment. You get one steer sick on your prairie dog treatments, that could skew your whole results. So I shouldn't say I wasn't really impressed. This is hard research to do. Range science, I think, would be easier if it was rocket science because there's actually laws of physics. We don't have any laws of ecology. So let's take it to the next best thing. Justin Durner, 2006 and colleagues. This is out of a Agricultural Research Service station in Cheyenne, Wyoming. Justin Durner does excellent work. And the other thing I like to point out about Durner's work is Durner is not coming from some anti-livestock agency. Justin Durner is very practically minded research, good relationships with producers. So Justin Durner went to work on this. They did a 6-year study. This was in shortgrass prairie, so probably applies best anywhere west of Chadron. They showed that increased occupancy led to decreased gain on steers. So if they had pastures that had 20% of the pasture had a prairie dog town on it, those steers gained about 5.5% less over a 5-month grazing period. They translated that to dollars per steer, about $15 a steer. When you translate that to dollars per acre, which I think is probably a more valuable measure, that works out to about 90 cents an acre. Basically, you just need to know that it's more than 1 acre per steer in that shortgrass prairie country. 60% occupancy reduced the steer gain by about 14%, worked out to about 38 bucks a steer, or $2.25 an acre. Okay, so this is probably the best design we have right now. This is the best information we have right now. I would really like to see this repeated further east in some mixed grass prairie. And Durner speculated as well that these numbers would likely be higher. The shortgrass prairie tolerates grazing really well. So even on a prairie dog town in shortgrass prairie, you're still having production of shortgrasses that are relatively palatable and accessible to livestock. As we move into mixed grass prairie, that plant community changes a little bit. Those numbers would be somewhat likely to change. But again, this is the best we have right now. Applies really well anywhere west of Chadron, which is really where most of the prairie dogs are anyway. So I would argue this states that we have competition. There is some level of competition here, but competition is scale dependent. I asked you to keep that scale in mind. So at the continental or at the country scale, prairie dog populations have been decreased by upwards of 95%. Any large scale competition at that scale is highly unlikely. Prairie dogs are not a major problem of large-scale ranching or range management. However, at the pasture scale or at the ranch scale, and this is actually a picture of my PhD research site. Ranchers are legitimately concerned here. We have potential for competition at those scales. Grazing intensity matters as well for this competition. Photograph on the left reminds me of the dairy cow playgrounds I grew up with in Minnesota. They look a lot like golf courses. At that level of grazing intensity, we almost definitely have competition. Photo on the right, more conservative stocking rates, lighter grazing, that competition level is likely much lower. Occupancy matters. Pastures or paddocks with high occupancy are more likely to promote competition. Derner's work showed a linear relationship between prairie dog occupancy and steer gains. It's also a function of pasture size. If livestock are able to move between occupied areas and non-occupied areas, there would be less likely to be competition. Then precipitation matters. This is some of the newer work. Augustine and Springer in 2013 out of Colorado State found that under high precipitation, livestock were actually facilitated by having access to prairie dog towns. The vegetation that grows on prairie dog towns is supplemented with an awful lot of nitrogen simply by virtue of being surrounded by lots and lots of little rodents. And also vegetation that has been grazed recently and is actively regrowing is more palatable, more digestible, and has higher nutrient values. So these researchers found that in years of high precipitation, cattle actually gained better if they had access to prairie dog towns. Now, most of Derner's work took place during a drought period. So you can see where that precipitation may be a major factor that should probably be explored a little bit further. I should point out that Augustine's work also showed competition during drought. So let's condense that a bit. Competition is likely to occur at small scales, at higher stocking rates, in pastures with high occupancy, and during periods of low precipitation. I think that's been demonstrated fairly well. I don't think anybody would argue with me about that. This is the more interesting one to me. Facilitation might occur when we have adequate or high precipitation, and both competition and facilitation can occur in the same pasture and in the same year. Because as we know in the high plains here, precipitation might be great in the spring. We might have plenty of production. Later in the year, that might completely shift. So where are we left? We have a species that I think has been critically evaluated and determined to be a keystone species. They're a critically important component of prairie ecosystems in North America, and they compete with livestock for forage. With that level of competition varying based on the things we talked about before, occupancy, stocking rate, precipitation, and spatial scale. Now what? Here's what we normally do. Traditional answer has been controlled. I don't know if anybody played this computer game years and years ago. This was my introduction to prairie dogs. Growing up out east, we didn't have these animals around, so this was what I got. That one with the big teeth, it's got rabies and it's coming for you. You got it. Anyway, prairie dog numbers have been reduced throughout their range, primarily to facilitate livestock grazing. Methods can include things like grazing management. You can actually reduce the rate of expansion of prairie dogs simply by altering your grazing management if you leave enough high structure vegetation. And this is easier east than it is in the Cheyenne shortgrass areas. You can actually reduce that spread. People have tried to facilitate predators. I've heard of people putting roost posts for golden eagles on their prairie dog towns with the idea being that they might reduce the numbers. We've also used recreational shooting. in order to reduce numbers. All the research on that seems to indicate that you can't eliminate a prairie dog colony by shooting it, but you can reduce slow or stop spread if you had enough recreational shooters. Probably the most common would be toxicants, would be poisoning. And the first time I gave a talk of this topic, I was asked, well, why don't you talk about prairie dog control? I'm sorry, I don't know a lot about prairie dog control. I can't give you the prescription for poisoning, I'm sorry. Traditional answer has been control. We've used these various methods. I won't step away from the mic. But various toxicants, various versions of poisons have been used by federal government, by state government, by tribal organizations, by private landowners for about 100 years. They've been used at wide scales, and they've been used with pretty good effectiveness in terms of reducing numbers. Yes, Jaden?
For killing the prairie dogs, what about gassing them? On our family farm, a lot of times we put a pipe on the end of the truck and stick in the whole area and gassing them for a while.
Yeah, so the publication I used for the numbers that you'll see in a moment was an extension publication out of University of Nebraska. And it breaks down various methods that people use and gives us a price per acre, which was what I was most interested in. But what you're mentioning, Jaden, if I had to guess, would be on the cheaper end of things, but also less effective on a larger scale in terms of time commitment.
So we've discussed in a class how if you reduce coyote numbers, they tend to have larger litters. Is that also a trend for prairie dogs?
If you didn't hear that question, it was if you reduce the numbers of prairie dogs, do they have larger litters? And I haven't seen any evidence of that. But if you did it in such a way that there was a lot of resources, there's no reason it couldn't be that. Again, they actually have relatively small litters, fairly low fecundity for a rodent, 3 to 5 per year per female. As I mentioned, the most common and most effective control method that's been used has been these toxicants. Extensive poisoning by livestock producers began in about the 1880s. Federally subsidized poisoning came into effect in about 1915. These practices quickly became institutionalized among federal, tribal, state, and county governments. The great majority of this poisoning is done with livestock production in mind. There are a couple other options, or a couple other reasons, especially in urban areas where poisoning might be used, but in general, it's due to this competition aspect. So financially, costs vary widely, and I mean very widely, with approximately an order of magnitude. Depending on the chemical used and the labor costs, zinc phosphide is commonly used, $15 an acre, again based off a University of Nebraska extension publication. About 75% reduction. Chlorofascinone, I'm going to go with, I'm not a chemist, $20 an acre, 90% reduction. There are fumigants that can be used that range about $50 an acre, about 95% reduction. Okay? So we have a wide range of costs paired with relative levels of effectiveness. So what I was interested to do was take this information and tie it to Derner's work in terms of reduced steer gains. So financial scenario 1. Again, this is the best numbers I can find. Toxicant prices from 2011, livestock prices from Derner's work in 2006. I'm making a few favorable assumptions, and these numbers will of course vary. Let's assume our pasture is 60% occupied. We're losing about $2.25 per acre per year. Toxicants and labor about $15 an acre. This is my rosy point here. One application, 100% control. This doesn't happen. I'm also ignoring things like colony expansion and recolonization. I'm assuming no recolonization and immediate vegetation recovery, which again is rosy. Takes about 7 years, okay, 6.7 years. Say it's 20% occupied, we're losing 90 cents an acre. Toxicants and labor again at the cheap end, $15 an acre. One application, 100% control, no recolonization, 16.7 years. Okay. So does it make sense? Based on the numbers that I just gave you, maybe, but a few folks have looked at this in more detail. This was a 1984 paper. Again, this hasn't been looked at as much as I would like, but it was in the Kanawha Basin in South Dakota. And these researchers looked at it from two perspectives, one being the U.S. Forest Service, where everything costs more, and one on private lands using that zinc phosphate bait prices. Not economically feasible in either case. So, I apologize for the wordy slides. I yell at students for this, but if colonization is high, if the entire colony could be removed, if labor is provided by the landowner, cattle prices are high, and vegetative recovery is fast, maybe, maybe. If colonization is low, recolonization is likely, contractors must be hired, cattle prices or rent are low, and vegetative recovery is slow, no. Guess which one is usually true? The bottom one. Those are some economic ideas, right? Doesn't typically pencil out, but maybe. Ecologically speaking, there's direct and immediate effects. You kill non-target animals, which is what you mentioned. Midterm effects, that prey animal disappears, those predators no longer have a prey source, so they either die or move on. Vegetation stature changes, that usually takes a few years. Under high precipitation, you can see that come back in 1 to 3. The plant community shifts. It shifts to plants that don't necessarily tolerate the activities of prairie dogs quite so well. That has effects on things like ground nesting birds. A lot of our ground nesting grassland birds depend on short structure vegetation. The burrows collapse, so they're no longer a habitat option. Again, scale matters here, and I end up saying that quite a lot too. Localized poisoning on a small scale is probably not going to have much of an effect, but at a large scale, like we've been doing it for the past, 100 years or so, dealing with a species that's already been reduced 95 to 99%, starts to add up. As far as I can find, there's really no positive ecological impacts. Again, from a traditional rangeland health measurement system, we would put an area that had been poisoned 10 years ago higher on the scale than we would put one that was active prairie dogs. But from a real ecological perspective, there's really not much we can say good about poisoning. Some might argue an a reduction in invasive plants. So prairie dogs create a bunch of bare ground, and you see a lot of weedy species on these prairie dog towns. But the invasive plants, the cool season introduced grasses that I lose sleep over actually do much, much worse on prairie dog towns. So I almost got kicked out of North Dakota for saying, well, we want to get rid of Kentucky bluegrass, maybe we just need a few more prairie dogs. So we've got economics that may or may not pencil out, usually not. We've got ecology that says, no, we shouldn't. Where do we go from there? We move into legislation. And this really illustrates that dichotomy from YouTube I mentioned earlier. Prairie dogs have been proposed as an endangered species several times. Most recently in 2009, they support a number of threatened and endangered species, including the black-footed ferret that we mentioned earlier. They've been highly reduced. They're at risk of plague. Ecologists are working towards protecting ecosystems instead of protecting species. So by protecting the prairie dog, the idea would be we can protect all these other species. The latest decision was protection is not warranted. The decision before that said, yeah, we probably should, but we don't have the resources to do it. So the kind of the status quo right now is we spend a lot of money poisoning prairie dogs, and then we spend a lot of money protecting species that depend on prairie dogs. There's captive breeding of black-footed ferrets going on right now that costs quite a lot of money. So we've got a real catch-22 on our hands. So this is one end of the legislative spectrum. The other end of the legislative spectrum, Nebraska Revised Statute 23-3803. Prairie dogs were legally classified as a rangeland pest in Nebraska from the 1930s until 1995. That legal designation went away for a while. In 2012, the unicameral passed the Black-tailed Prairie Dog Management Act. This act authorizes counties to create prairie dog management plans and prevent expansion of prairie dog towns onto neighboring properties. And what that means is if you have a prairie dog town on your property and is expanding into the neighbors, counties are authorized to control those prairie dogs on your property with or without your consent. So, two very different ends of the legislative spectrum, right? I don't know exactly where that's going to go, but they're definitely in conflict. Definitely in conflict. So, for now, numbers appear to be relatively stable, but maybe lower, I shouldn't say maybe, but are lower than will be required to fully support some other species. Prairie dogs are at risk of plague, habitat loss, as well as poisoning. There's been a lot of pushback against the Black-tailed Prairie Dog Management Act that I brought up, and that will likely continue. There will almost definitely be more push to be listed under the Endangered Species Act, which will be met with vigorous defense, as most listings are, but this one will in particular. But I hope I've demonstrated that black-tailed prairie dogs are a keystone species. They're a critically important of grassland ecosystems, critically important component that also happens to compete with livestock for forage. So if we're going to continue to have policies in one area that classify them as a rangeland pest, while others are pushing to categorize them as a legally defended endangered species, we're not going to make any progress here. So with that, thank you for coming, and I'll attempt to answer a few questions if anybody has any. Yes?
In the bubonic plague, does it affect cows?
The question was, does the bubonic plague affect cows? And that, I'm sorry, I don't know an answer to. People can get it, but thanks to modern antibiotics, we generally do fine.
Do you have any numbers? Because this is my husband's big issue, that prairie dogs, cows and horses break their legs because of prairie dogs. Do you have any numbers and know of any references to that?
Okay. I was expecting this question, and I was avoiding it on purpose. So the question was, do we have any numbers on how many cattle and horses break their legs on prairie dog burrows? The answer is no, I don't. If you look at the scientific literature, the general statement is there is no good evidence for this. We don't have any numbers on this. When I ask students in class, half my students raise their hand and say, yes, I've seen it. When pushed a little bit further, more and more of them put their hands down. But I always have somebody who says they've literally seen it. If that does happen, that changes the economics very quickly, right? So I guess my conclusion on this is that it likely does happen less often than people tend to think. And I think that management can play a role in it. If we're pushing cows quick across a prairie dog town, it'd be a lot more likely to happen. But no, the scientific literature really does not have reports of this. So, yes?
Has there been any work been done on interbreeding between two species?
Oh, so the question was on interbreeding between prairie dog species, and I've not seen anybody who's looked into that, no.
Homo sapiens and others,
Sure. Any other questions?
I've heard that bubble gum, is that actually harm prairie dog, or is it just
I'm sorry, I've never heard of bubble gum.
tossing it down the hole, supposedly it doesn't pass?
Well, I suppose it's possible there. But, all right, well, thank you all for coming. I'll see some of you in class tomorrow.